Hi, I am Syed on Maths Online. Today we will be discussing about the properties of Laplace transform. In the previous video we already discussed about this property. We will continue with few problems based on the property of Laplace transform.
Let us take the next question. Evaluate integral 0 to infinity cos 60 minus cos 4t whole divided by t into dt. We know that Laplace transform of f of t is equals to 0 to infinity e power of minus st f of t into dt. That's the basic formula for the Laplace transform. Or we can even write it in the form of integral 0 to infinity e power of minus of st. We'll take f of t value to be equals to cos 60 minus cos 4t divided by t. Therefore, if I replace that value of f of t as cos 60 minus cos 4t whole divided by t into dt will be equals to the Laplace transform of f of t value. So Laplace transform of f of t is cos 60 minus of cos 4t whole divided by t. Now we need to just evaluate Laplace transform, which is of the form f of t by t. Laplace transform of f of t by t form. So let us take this as equation number 1. Let f of t be equals to cos of 60 minus of cos 4t. We'll try to find out its Laplace transform. Laplace transform of f of t will be equals to Laplace transform of cos 60 minus Laplace transform of cos 4t. We know the Laplace transform of cos 80 to be equals to s by s square plus a square. In this case, a is 6, so it is 6 square minus s by s square plus a square is 4, so 4 square. Further, you can rewrite that as s by s square plus 36 minus s by s square plus 16. That will be equals to f bar of s. Therefore, Laplace transform of f of t by t, we know the formula, which is nothing but integral s to infinity f bar of s into ds. That's the basic formula we have. So now let us try to plug in the value of f bar of s. That will be equals to integral s to infinity. We know the value of f bar of s. It is s by s square plus 36 minus s by s square plus 16 times of ds, which will be equals to integral s to infinity s by s square plus 36 times of ds minus, apply the integral for the second term, integral s to infinity s by s square plus 16 times of ds. So let us try to integrate these two integrals. We know the basic formula for integral of dx by x, which is nothing but log of x. So here also, in the integral, to get in that form, I have to multiply and divide by 2. So it becomes dx by x form. In the second integral also, I'll divide and multiply by 2. So it is half times of its integral value will be log of s square plus 36 minus half times of the second integral is also log of s square plus 16. and the limit values are from s to infinity. Let us take half common outside and rewrite that value as log of s square plus 36 minus log of s square plus 16. Limit values are from s to infinity. This is in the form of log m minus log n, which will be log m by n form. So it is log of s square plus 36 divided by s square plus 16. Limit values are s to infinity. Let us apply the upper and lower limit values. We get half times of upper limit value is limit as s tends to infinity. It is log of s square plus 36 divided by s square plus 16 minus the lower limit value is s itself. You get the same expression, log of s square plus 36 whole divided by s square plus 16. So half times of, we know the limit value will be 0, the first term. The second term is log of s square plus 36 divided by s square plus 16. That can further be written as half times of negative sign. When it goes inside, it becomes reciprocal. You will be getting log of s square plus 16 divided by s square plus 36. Just taking negative inside and make it as reciprocal value. Or further, I can take it as log of s square plus 16 whole divided by s square plus 36. That half will become power using the basic properties of logarithm. It is in the form of log m power of n form. But power half represents square root. Therefore, I can write in the form of square root, log of square root of s square plus 16 whole divided by s square plus 36. On the left hand side, you have Laplace transform of cos of 60 minus cos of 40 whole divided by t. We'll try to substitute this expression back in equation number 1. So equation 1 will imply, so equation 1 is your Laplace transform cos 60 minus cos 40 divided by t. That's the value we have got. Right hand side, left hand side has to be evaluated. Therefore, we have integral 0 to infinity e power of minus of st cos of 60 minus cos of 40 whole divided by t times of dt is equals to, we have already calculated Laplace transform of cos 60 minus cos 40 divided by t is nothing but log of s square plus 16 divided by s square plus 36. So we'll take the value of s to be equals to 0, so that e power of 0 will become equals to 1. So therefore integral 0 to infinity, because e power is not there in the given question. Therefore we are making that to be equals to 0. So now we are left out with cos 60 minus cos 40 divided by t into dt will be equals to log of. So put the value of s as 0. You will be getting 0 plus 16 divided by 0 plus 36, which will be nothing but log of square root of 16 by 36. Further, if you try to simplify this one, you will be getting log of root of 16 will be 4 and root of 36 will be 6. So cancel out that value, 2 times and 2 3 times. So you are left out with log of 2 by 3. That's the required solution. Let us move on to the next question. Next question is, evaluate integral 0 to infinity e power of minus of t sin t whole divided by t into dt. Let us try to evaluate this integral. So we know the basic formula for the Laplace transform, that is integral 0 to infinity e power of minus st f of t into dt is nothing but Laplace transform of f of t. That is the basic definition of Laplace transform. Therefore, integral 0 to infinity e power of minus of st. So, if you try to compare in the question, the value of f of t is taken as e power of minus of t sin t divided by t times of dt. That will be equals to Laplace transform of f of t in this case is e power of minus of t sin t divided by t. We just evaluate the Laplace transform. So f of t value that we have taken is e power of minus t sin t whole divided by t. So let us take this as equation number 1. So we need to just evaluate the Laplace transform. So let us take Laplace transform of e power of minus of t sin t. That will be equals to Laplace transform of sin t, where s will shift to s minus of a. So we know the basic formula, Laplace transform of e power of at f of t is nothing but f bar of s minus of a. So that means s is being shifted to s minus of a. So since you have e power of minus of t sin t, we are finding out Laplace transform of sin t. And since the value of a is minus of 1, s is being shifted to s minus of minus 1. So minus of minus will become plus. You will be getting s tends to s plus 1. So Laplace transform of sin at is a by s square plus a square. So here the value of a is minus of 1. So 1 by s square plus 1 whole square. So it is 1 by s square plus 1. S is being shifted to s plus 1. So s plus 1 whole square plus 1. So replacing the value of s by s plus 1. We get s plus 1 whole square plus 1. That is nothing but f bar of s. So you have just evaluated Laplace transform of e power of minus t sin t. So now we need to find out Laplace transform of e power of minus of t sin t divided by t, which is of the form Laplace transform of f of t by t. Therefore, Laplace transform of e power of minus t sin t divided by t, which is f of t by t form. We know the formula, integral s to infinity f bar of s into ds. We know the value of f bar of s. So therefore we have integral s to infinity f bar of s is 1 by s plus 1 whole square plus 1 into ds. We'll try to simplify the denominator value, s plus 1 whole square. That is integral. We know integral 1 by 1 plus x square dx is nothing but tan inverse of x. That's the basic integral formula we have. So we get tan inverse of x. X value in this case is s plus 1. Limit values are s to infinity. So apply the upper and lower limit value. Tan inverse of infinity minus lower limit value is s itself, therefore s plus 1. Tan inverse of s plus 1. We know tan inverse of infinity is pi by 2 minus tan inverse of s plus 1 as it is. That will be equals to cot inverse of s plus 1. Pi by 2 minus tan inverse of s plus 1 is cot inverse of s plus 1. That is the basic formula you need to remember. So substitute this value back in equation number 1. So equation 1 will imply, so we have equation number 1. So we need to plug in back in equation number 1. So we know the right hand side value. So we need to just evaluate the left hand side value now. Therefore we have integral 0 to infinity e power of minus of st e power of minus of t sin t whole divided by t into dt. That will be equals to. So we have already evaluated Laplace transform. Its value is cot inverse of s plus 1. Now put the value of s to be equals to 0 because in the integral we don't have e power. So e power of minus st will be equals to e power of 0. E power of 0 is 1. Therefore we have integral 0 to infinity, that has become equals to 1. Therefore we are left out with e power of minus of t sin t divided by t into dt will be equals to cot inverse of s value is 0 plus 1. So that is nothing but cot inverse of 1. But we know cot inverse of 1 is nothing but pi by 4. Because cot inverse of 1 and tan inverse of 1 both are equals to pi by 4. That's the required solution. That's all I have for today. Thank you.